All right, this video is to review systems of inequalities. Now, some classes reviewed systems of equations previously. Some classes have not yet, but just remember that a system is more than one graph at the same time. So a system of inequalities just means that I'm going to be graphing multiple inequalities on the same grid, and then we're going to talk about solutions for that possible system. So a system of inequalities can have the following solutions. It can have many solutions. And when we look at a graph and it overlaps, the double shaded area or on any solid line would be part of the solutions to the system. So normally if it's just one inequality, it's on a solid line or in the shaded region will be one of the solutions. Well, if we're overlapping or we have more than one inequality, we want to see where it's double shaded, or it could be on the solid line that connects that double shaded area. There could also be no solution. If the graphs do not overlap at all or have any points in common, then that would be an example of no solution. So first up, we're going to look at this graph and we're going to write the equations of these two inequalities, and then we're going to determine whether these points would be solutions or not. So you can see on this graph right now, I have a double shaded area. That's the side on the left. I have two sides that are single shaded. That's the top and bottom. And then on the far right, that's not shaded at all. So we're going to start with the first inequality, equation 1. So I need a y-intercept and a slope in order to find the equation of that inequality. So I'm going to zoom in. I can see where the y-intercept is at 3. And then I would need another good point on this line, which looks like right here at 2, -1 would be a great point. So between these 2 points, we are going down 4 and over 2. -4 over 2. So down 4 over 2 would be the same as down 2 and over 1, or just -2. So our slope of this line is -2, and we know it crosses the y-axis at 3. So y-intercept is 3. The slope is -2x. Now we just have to figure out the symbol that comes after the y. So equation 1, I can tell is shaded below that line. I can see the single shaded and the double shaded. That means it has to be below, and it's a dashed line. So this is going to be less than. Remember, if it's equal to underneath, that would be a solid line. All right, then for my equation 2, same thing. I need the slope and the y-intercept. So the y-intercept looks like it's at -1. I'm going to try to find another good point on the grid. This one's a little trickier. I think either my line has shifted or we're going to use this point way over here. Let's see what that is. All right, I think my line did shift a little bit, but we can see these points are pretty close to crossing. So we're going to just go ahead and say that the slope is up 1 over 1. I think that's what I put on the poster as well. So y, we'll come back to the symbol in just a second. The slope is 1x and it crossed at -1. So this line is solid, so it has to be an equal to, and then it's shaded above the line. I can see that it's shaded the double shaded area. On the other side, it's shaded up, so that's going to be greater than. So even if I didn't write the equations, we could still figure out where these points, or if these points are solutions. So I'm going to go plot all these points first and talk about the ones that are and the ones that are not solutions. So we've got point A is at -5, -3. Point B is at 0, 3. C is at -2, -6. And D is at 4, 1. So I've got points in all the different locations here. So in order for a point to be a solution to the system of inequalities, it has to be double shaded or work in both equations or on a solid line that would be attached to that double shaded area. So I'm going to use my highlighter. So I've already talked about, you really can't see it, but this area right here is the double shaded area. So anything in that double shaded or on this solid line that is attached to that would be a solution. So if any point were on that part of the solid line, it would be a solution also. So there's only one of these points that's in the double shaded, so that would be A. So for sure A is a solution. The other points B would be a solution if that part of the line was solid, but it's dashed. So B is a no because it's not equal to on a dashed line. C is not double shaded, so that's a no. And D is not shaded at all, so that's definitely a no. So we're looking for double shaded and or it could be on a solid line that's attached to that double shaded. All right, so next up we have Diego started an exercise program in which each week he works out at the gym between 4.5 and 6 hours. And he walks between 9 and 12 miles. We're going to use the graph to show some possible combinations of working out and walking. Okay, so first up, we know that at the gym, he is there between 4.5 and 6 hours. So it's not equal to 4.5 and not equal to 6, but somewhere between that time frame. So when I go to the gym, I'm going to go to those numbers. I'm going to go 4.5. And we're going to draw a line straight up at 4.5. Not a solid line because it didn't say equal to, it said between. And then 6 hours. So I need another dashed line. So this is the time frame this person is at the gym. So we could shade anything in between here would be solutions for times that this person is at the gym. Okay, then it says that he is going to walk between 9 and 12 miles. So again, not equal to, somewhere between. So I'm going to go walking, and I'm going to go 9 miles and 12 miles. So he's going to walk somewhere between those. So the solutions for this system is going to be in the double shaded area or where they overlap. So that's right here in this little square in between. So I would want to give some combination of time at the gym and miles walking that would be somewhere in between those lines. So there's lots of possibilities. I'm just going to pick one. So one option would be 5 hours and 10 miles. So I could say that he is going to work out 5 hours at the gym, and then he's going to walk 10 miles. Again, there's lots of combinations in there. We're just looking to see where does this graph overlap and what is one possible combination. All right, now we're going to practice graphing these inequalities 2 at a time and seeing where they overlap. Again, practicing with slope and y-intercept. I'll even pull up my calculator in just a second and remind you how you could use your calculator to help you graph these inequalities as well. So starting with the one on the top left, we're going to pick 2 colors using colored pencils, and then you might want a ruler also. So I'm going to start with blue. This one, the slope is -1/2 and the y-intercept is 2. So I'm going to start at 2 on the y-axis and the slope is -1/2. So that means I need to go down 1, right 2, down 1, right 2. And remember, you want to get as many points as possible. That's going to help you draw a straighter line. Okay, so something I need to pay attention to is whether my line should be solid or dashed, and then which way I'm going to shade. So this inequality is less than, so that means I'm going to shade below in a second, and there is no equal to, so that it's going to be a dashed line. So I'm going to line up my ruler. I'm going to draw a dashed line between these points. And then I would shade below. So your shading doesn't have to be perfect, just indicating, hey, all of these points below this dotted line would be solutions just for that one inequality. Okay, now I go to the second one. The second one, the y-intercept is 2 and the slope is +1/2. I notice that it is less than, so that means when I shade this one, I'm going to go below, and it has an equal to, so I'm going to need a solid line. So I'm going to start at 2 again. This time the slope is positive 1/2, so I'm going to go up 1 over 2. More points is going to give you a better line. This time when I connect the dots, we're going to draw a solid line. We would be shading below this line, so anything below. So you want to pay attention to where is it double shaded. So for this, anything in this area, so if you want to get a highlighter to help yourself out, so you can see where is it double shaded. So there's lots of points in that double shaded area, or it could be on that part of the solid line that is connected to the double shaded area. Okay, next up we have y is less than 3x minus 2. So our slope is 3 and our y-intercept is -2. Less than means I'm going to shade below and there's no equal to, so it will be a dashed line. So I'm going to start at -2. My slope is 3, so that means I'm going to go up 3 over 1. I'm going to connect those with a dashed line. And we're going to shade below. So if you're not sure which way should be below, think about a test point. If I plugged in the point 0, 0, if I did 0 is less than 3 times 0 minus 2, this would mean 0 is less than -2. Well, that's not true. That's a false statement. So I don't want to shade where that test point is. I want to shade on the opposite side. So I'm going to get rid of my test point and I'm going to shade on this side of the line. That would be below. Okay, now we go to the next one. Next one, the slope is -3 and the y-intercept is 1. This time it's greater than, so I'm going to shade above, and there's no equal to, so it's going to be dashed. So we're going to start at +1. The slope is -3, so that means I need to go down 3 and right 1. Or if you want to go up 3 and left 1. So you line up. This time we need a dashed line. We're going to shade above this time. Again, if you're not sure, you can pick a test point and plug that in. And if it's true, that's the side that you need to shade. If it's false, you want to shade on the other side. Above the line this time. Whoops, I accidentally erased. So above the line, hopefully you can see where it's double shaded. Mine just looks messy right now, and it probably looks messy on the poster on the board as well. But hopefully with your colored pencils or highlighters, it'll be easier to see where you double shaded. Okay, so let's practice using our calculator and see what it's going to look like on the calculator. So I'm going to go put these two inequalities, 3x minus 2. So right now it would just be a regular line. I go in front of the y equals, and if you have a colored calculator, this is where you change the color, and you're going to change the line setting. For the black and white calculators, I'm going to hit enter a couple of times till I see these triangles. A triangle on the top means that I'm going to shade above that line. A triangle on the bottom means I'm going to shade below. So I need to hit enter one more time so I have a triangle below for this one. So if I hit graph, I can see this was that original green line that I drew. Now these calculators don't do a solid or a dashed line, so you just have to know whether it should be solid or dashed. So I go back to y equals, I'm going to put the second one, -3x plus 1. I'm going to go in front of y equals, and this time it's a greater than, so I'm going to hit enter until I have that triangle on the top. I'm in a graph, and it's real easy to see whether you're in color or black and white. You can see where it's double shaded. You can see it cross-hatched, the directions there. All right, so next up we have y is greater than 1/2 x plus 3. So our slope this time is 1/2, and our y-intercept is 3. So I'm going to start at 3, and we're going to go up 1, right 2. This time it's greater than, so we're going to shade above, and there's no equal to, so that means it's going to be a dashed line. So I need a dashed line between these points. And then greater than, we're going to shade above. Our next one, 1/2 x plus 2. Our slope is 1/2. Our y-intercept is 2. So these lines are very close together. Notice the slopes are the same, so these lines are actually parallel to each other. So be real careful because these are really close. This one is less than or equal to, so we're going to shade below this line, and we need a solid line because it is equal to. So a solid line between these points. These lines are parallel to each other, so they're never going to intersect. And then I would shade below this line. So we're looking for where they overlap. Notice my blue and green don't overlap. The lines are parallel. One is shaded above, one is shaded below. I have this gap in the middle where there's no shading at all. They're not double shaded. So this would be an example where there is no solution. Any of these other graphs, they've got many points because they overlap, and there's all those points where they overlap each other. So this would be an example of no solution for an inequality system. All right, we've got one more. Y is less than or equal to -1/3 x plus 1. So my slope is -1/3. My y-intercept is 1. Less than or equal to, so I'm going to shade below. And we need a solid line since it's equal to. So we're going to start at 1 on the y-axis. Our slope is down 1, right 3. We want a solid line between these points. And then we're going to shade below. Okay, next we have y is greater than -1/3 x minus 1. So my slope is -1/3 and my y-intercept is -1. So slopes are same again, different y-intercept, so down 1, right 3. So these lines are going to be parallel. Since it's greater than, we're going to shade above, and it's not equal to, so this will be a dashed line. So I'm going to connect these points with a dashed line, and we would shade above. So here's another example of parallel lines, but these do overlap. We have this space right in the middle where those inequalities overlap each other. So anything between those or on that solid top line would be a solution to the system of inequalities.